Hey guys, welcome back to another video. So for this video, I'll be looking at the Kruskal Wallis Test. And the Kruskal Wallis Test is a one-way analysis of variance method based on ranks, which is obviously a non-parametric method. So the assumptions under which we tend to carry out a Kruskal Wallis test are the observations are independent both within and among samples. The variable of interest is continuous. The measurement scale is at least ordinal. The populations are identical except for a possible difference in location for at least one population. So the procedure in calculating a Kruskal Wallis statistic H are as follows. So we'll need to combine all the n observations from the k samples, and we'll need to order them from least to greatest. So we'll just and for the next procedure, we'll let Rj denote the rank of Xij in this joint ranking set, and large Rj is just the sum of each ranks in each sample. We're not going to be looking at what if there are ties in this example, but if there are a few ties among the ranks, we're going to assign each observations in a tied group the average of the integer ranks that are associated with the tied group and compute H, these average ranks. Now I'll probably look at this in another video, but for this video I'll be looking at an example without ties. So the hypotheses that we like to employ in a Kruskal Wallis test are H0. The k population distribution functions are identical, and the alternative, the k populations do not all have the same median. So our test statistic H will be given by this formula right here, 12 over n into n plus 1 times the summation of rj squared over nj minus 3 times n plus 1. And the rejection region is such that will reject the null hypothesis given that H, the test statistic, is greater than or equal to H alpha, and our alpha is the given region. Now for our example. So this example reads, we are interested in the effectiveness of three different car waxes A, B, and C. The number of days of protection. The data is shown below. So we have A, B, and C. And we're asked is there a difference in the effectiveness of three different brands of car wax? And we should test at a 5% level. So we have A being 44, 45, 46, 47, 48, 49, B being 40, 42, and so on. So for ease in calculations, what I'll do now is I'll switch to Excel to make the calculations much easier. So here is our data, and our data is it's not yet formatted, but it's as is. We just labeled the days and the brands accordingly. And what we'll need to do now is we'll need to rank from smallest to largest. So in this case, 40 would have a rank of 1. The next highest would have a rank of 2, and so on. But to make things easier, I'll just go ahead and sort these from smallest to largest. And we can see that from smallest to largest, and each brand is assigned either A, B, or C. So now we can go ahead and write the rank of 1, 2, and goes down all the way down to 3 up to the number of n's. The number of n observation is 15. So next we'll need to calculate the statistic H, and I'll break this calculation up in parts for visibility and to let persons see the different parts of the formula. So here we have our A, which is the sum of the ranks of the brand A, and right here we have B, RB, which is the sum of the ranks of B. Now let's start with A, so we just say equal, and we'll just select all the rank values that represents A. So we have A plus another A plus this guy plus this guy, and that's all the A's. Yes, and we'll just have enter. Now for B, we'll just say equal, and we'll sum all the ranks of B. So we have 1 plus 2 plus we have 10 plus 11 plus and 13 and equal. Good. So now for our C, we'll just say equal, look for all the C's. So we have 1 here 9 plus 1 here 12 plus 14 plus and 15, and we have 50. So we have RC being 50, RB being 37, and RA being 25. Now let's calculate this 12 over n times n plus 1, and that's just equal to n is 15 in this case, and we have 15 plus 1, which is 16, and we should have a division sign right here. Good. Yes. So there we have it, 0.05. So now for this summation right here, we have Rj squared over Nj. So this is just the sum of the ranks squared divided by the number of observations in each sample. So that's in A we have 6 samples, in B we have 5, and in C we have 4. So what we're going to have in this right here is just equal 25 squared, and we're going to divide the 25 by 6 and sum 37 squared, divide by 5 plus 50 squared, divide by 4, close bracket and enter. There we have 1002.967. So now on to this bit of calculations right here. We just need to multiply this 0.05 times 1002. Okay, so this right here should be, there should be a r squared right here, as is in this h statistic over here. So we're just gonna say equals 0.05 multiplied by 1002.967, and we have 50.14833. And now for this bit of calculation right here, we just 3 times 16, so that we have equals 3 times n, which is 15, plus 1, which is 16, and yes, and there we have 48. Now for the last calculation, we just need to group everything now, and we have h is equal to all of this guy right here, subtract 48, and we have 50 minus 48, and we have an h statistic of 2.148333. Now, if we recall our rejection region being reject, we'll reject our null hypothesis given that H, our test statistic, is greater than our H alpha. Now, in our Kruskal Wallis distribution table, which I'm going to pull up right now, we will need to see that we have three samples, A, B, and C. So in each sample, we'll need to look for the number of observation in each sample. So we have, for our example, we have in A we have 6, in B we have 5, and in C we have 4. So we need to look for 6, 5, and 4, and then we go across to the 5% level. Now we'll go down, and here we have 6, 5, and 4, and go across. We see that this is 5.661. So our H alpha is equal to, let's just write it here, equal to 5.661. Now okay, so this is 5.661, and our rejection region states that we should reject if H is greater than H alpha. In this case, we can see that H is not greater than H alpha, and as such, we cannot reject our null hypothesis. So we can conclude that there is no significant difference in the median of the brands of each car wash. So we cannot say that A, B, and C are significantly different in their protections. And that is the end of this example. So if there are any questions, just feel free to leave a comment in the comment section. I'll respond. Thank you very much for watching.